All right, good morning, everyone. In today's class, we'll be talking about a relational database, RDB, Relational Database Management System, RDBMS terminology. All right. So, what is Relational Database Management System? So far we have talked about normal database management system. It is the improvement of database management system. Okay. It is based on relational model introduced by EF Code. So EF Code was introducing relational model. Based on that, RDBMS is a database management system which is based on the relational model which was introduced by Dr. EF Code. In relational model, data is stored in relation table and is represented in the form of tuples or rows. So in our next topic, we'll be talking about what relation is and what tuples are. Okay, our DBMS is used to manage for what? It is used to manage relational database. Relational database is a collection of organized set of tables related to each other and from which data can be accessed easily. Relational database is the most commonly used database these days. All right, database. Most of your database like Oracle, Microsoft Access, SQL, SQL2, MySQL, MySQL2, all those things are based on RDBMS. Okay. You are lucky that I've taken out all this thing, all this material from your textbook. And so because of which some of the slide may contain lots of words. So please bear with me, but it will make the topic more clear. Okay. So what is table? In relational database model, a table is a collection of data elements organized in terms of rows and columns. A table is also considered as a convenient representation of relations. All right. Table will contain it is collection of organized data in the terms of rows and columns. I think we knew already what rows and column is, and we have seen table a lot, especially during first semester. We know from Microsoft Word how to create a table, right? So such things are simply called table. So a table is formed by a combination of rows and columns. So sometimes a table is also called a relation. But a table can have duplicate rows of data, while a true relation cannot have duplicate data. That means if you are creating a table for your class, then all your rows and columns will be, all your rows will be distinct from the other rows, right? Your name, your roll number, your address, and other thing will be distinct, that is different from others details. So because of which, though let me say like the table can contain all data even if it is duplicate. Okay. Whereas if you talk about a true relation, if you are supposed to use a relation in a proper manner, then there should not be any kind of duplicate data, like lal duoma cannot appear 2 times in a single table. Okay, so let's see. So this is how the table looks like. So here we have how many rows? We have 4 rows and 4 columns. Rows are those elements which are arranged horizontally. All right, these are our rows. 1 row, 2 rows, 3 rows, 4 rows, and these are the attributes. Like we said before, these are attributes. 4 attributes. We have 4 column and 4 rows, and these are the column. All right, 1 column, 2 column, 3, 4 column. Okay, what is a tuple? A single entry in a table is called a tuple or record or rows. So we'll often talk about this tuple, record or rows in the future lecture as well. So please mark these particular words. These are important things. All right. So you may already know when we talk about rows, but tuple, it may like create some kind of confusion. So please do know that tuple, records, or rows are all for the same, are having the same meaning here for relational database management system. A tuple in a table represents a set of related data. For example, the above employee table has 4 tuples or rows or records. So a single one could be, this can be a single record or tuple. So of this, we can take out this one. This is a tuple. This alone, all this alone. It's an individual. Rows are called tuples. Okay. And then what comes next? What is an attribute? A table consists of several records or rows. Each record can be broken down into several smaller parts of data known as attributes. The above employee table consists of 4 attributes: ID, name, age, and salary. So a table consists of several records, that is horizontal values. All right, there we have 4. Each record can be broken down. That particular, suppose you have ID, name, what else? ID, name, age, and salary, right? So such thing can be broken down into several smaller parts of data known as attributes. The above employee table consists of 4 attributes: ID, name, and employee salary. Let's see here. So what are attributes? We have said this alone is these are the rows or tuples, right? So if we broken down that rows, then only one will be displaying a single value. This only one will shows that it is one of the attributes. So we have 4 attributes. All right, these are the attributes name. These are the attributes. These are the rows or tuples. Okay. What are the attributes of ID? If you are asked, then you have to answer 1, 2, 3, and 4. All right. And likewise, what are the attributes of name? These are not attributes. These are attributes name. Okay. ID, name, age, salary are attributes name, and then these are the value of the attributes. Okay. Then attributes domain. What are attributes domain? When an attribute is defined in a relation, that means when we are mentioning about relation in the table, it is defined to hold only certain type of value, which is known as attribute domains. All right. When you introduce any kind of attributes into the table, then that means that particular attributes have to hold, it has to hold certain value. All right. Hence, the name will hold the name of the employee for every tuple. If we save employee address there, it will be violation of the relational database model. That means we have ID, name, age, and salary, right? So in name attributes column, if you accidentally save address, then it can be a violation. That means we are violating the rules of the relational database model. Let's see an example here also. So this, why we introduce name attribute is to hold the names of the employee, right? But this one is, in this case, we are entering the address of someone address. So this is the violation of the rules. So because of which this is inappropriate. So under name, only name should be mentioned. Okay. So likewise, you have to create a table. So what is domain? A domain is a set of permitted value for an attribute in a table. It is a set of permitted value. We have talked about domain attributes. It is quite similar with that one. Okay. For example, a domain of month of year can accept January, February till December as values. A domain of dates can accept all possible valid dates. Date, if it is date, then it can accept all possible valid dates, etc. We specify domain of attributes while creating a table. An attribute cannot accept values that are outside of their domains. So what does domain means? Domain is a set of permitted value for attributes. That means some kind of rules that we have made. Under name, only name will appear, and under age, AGE, there cannot be character. All right, or the age should be below 63. Likewise, you can make some kind of constraint. Whereas if your domain, if your attribute is month of the year, like suppose here we have month of the year, then here we have to see like January or December or March, or we cannot see Ajit here, right? Because that particular attribute is mainly for month of the year. Whereas if it is date, then kind of date like 1 to 31st. All right. So that's what it talk about. For example, in the below table student, the student ID field has integer domain. Integer domain. So that field cannot accept a value that are not integer. For example, the student ID cannot has value like first 10.11 etc. First amo 10.11 ang chika I accept they don't issue because the domain for this student ID is integer. Integer ini accepted 1 to infinity. Tro fraction accepted or letter accepted. I think we are clear what domain means. The rules, some kind of rules that we have permitted to for and attributes in a table. Okay, and then we'll jump on to relational data integrity. This will contain a little bit content, a little bit explanation. So if I will provide this particular slide along with the previous slide to the group, and you please download it and compare with the notes which you have. Okay. Relational data integrity from the relational data structure, that is the table. All right, it is evident that most of the relations have an attributes which can uniquely identify its tuple. Tuples mean rows. Some in the relation, in some cases, there can be more than one attribute which can uniquely identify its tuple in the relation. This attribute is called the candidate key. In other words, the candidate key is an attribute that can uniquely identify a row in a table. That means, as we have seen before in the other relational table as well, relation or table as well, each row are different from other rows, right? Let's see here. The first row and second row are not similar at all. First row is not one, Jatinayan, Chaitanya, Dairabak, Akra, age is 27, and the second one is 102, Ajit, Delhi, 26. So what does a relational candidate key means? Which can uniquely identify its tuple relation. That means it distinguishes the relation, the tuples in the relation. In some cases, there can be more than one attribute which can uniquely identify each tuple in the relation. This attribute is called the candidate key. In other words, candidate key can be attribute key table. This candidate key was explained in the previous or class before the previous class under different types of keys. So here we have element table. In the above table, the attribute symbol, name, and atomic number can uniquely identify its row. Right? Symbol, name, and atomic number can uniquely identify its row. So anyone can be candidate key. So is this same with this one? No. Is this same with this one? No. No, no, no. Is this same with this one? No, 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 no. Likewise, this, and this, though these are the other thing, but if we keep on collecting the element of, have you ever heard this thing about, most of you are not science student. We have studied this thing in even class 10, even in class 10, I guess you will also study element table in chemistry. Aluminum, ions, nickel, copper, more to come, right? So their melting point, at some point, this melting, the boiling point and the melting point of some of the element will be same. So because of which this true cannot be taken as a candidate key. But this atomic number, name, and symbol never be the same, right? So because of which this and this can be distinguished. So because of which these attributes can become what? The candidate key. Whereas if you take name as candidate, candidate key, then it can be used because aluminum and iron, the name is always different, right? Iron, nickel, it's always different. This one also there, atomic number is always different. So because of which any of these three can be taken as the candidate key. Since the body of relation is set and sets by definition, we do not contain duplicate elements, right? We do not contain any duplicate elements. It follows that any given time, no two tuples or a relation can be duplicates of each other, or in other words, no two rows can be the same. So what kind of properties must be followed by a table in order to have a candidate key? Let R be the relation. That means let R be the name of the table with attributes, and their attributes be A1, A2 till AN, right? The set of attributes means the actual value of a table is said to be a candidate key of R if and only if, number one, at any given time, no two distinct tuples of R have the same value for AI. No two distinct value. No two distinct tuples. Distinct tuples are this, all this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Those 6 tuples of R have the same value for AI, AJ, AK, AL, likewise, right? So A, I, and AJ do not have any similar values. Or minimality, no proper subset of set has this uniqueness property. So these do not have any proper subset, right? These, what is subset and proper subset? Suppose we have two tables, element table and element one table. And in element table, we have this much. And in element one table, then we have except AU, all this. That means B is the subset of element table. Element table one is the subset of element table, or it is the proper subset of element table. That means what is subset? Subset tak suanin hemia athara table thara omsong kha tahiana in angvekang mo in angche chevek amar si proper subset kan ti suanin kha table kan ka table ka value na ita ka table le he table hian in dang nam na pakhalan amar chu he table dong long chu ta hian om ve vek tho chu chun dang nam na tak chu hei tak hin tiamang tro chu nianga chuanin has no uniqueness property heti ang properties ka nei ve da tur ani chu. Every relation has at least one candidate key. It is for sure. Its table must have at least one candidate key because at least the combination of all its attributes has the uniqueness property, right? Uniqueness property. In the case of base relational relationship of base table, one candidate key is designated as primary key and the remaining candidate are called alternate keys. For example, in the element table, the relation has 3 candidate keys. We choose any one of them as a primary key. So if we choose the symbol as a primary key, then the name and atomic number become alternate key. But there are no hard and fast rule to choose the primary key from the list of this matter. So table must have at least one candidate key, but it is not a hard and fast rule to select which one to be the primary key. For table, we say that on that particular element table we can have three candidate key. So any one of them can be selected as a primary key. But here in our example, they choose symbol as a primary key. Then those other two will become an alternate key. Alternate key kan ito what is primary key kan ito bok draw. Or if you are like the designer, the database designer, you can choose the atomic number as the primary key. That means atomic number will uniquely identifies the particular the whole table from other table. Okay. These are just the explanation of some primary key and alternate key. And then the term candidate key and primary key should not be abbreviated to just keys. So we should know that we should not simply use keys for that particular, like what are the keys for that one, for that table. All right, you should write the complete sentence, the complete words. If it is primary key, then primary key, because there are lots of keys in relational model, like candidate key, primary key, alternate key, foreign key, search key, parent key, encryption key, super key, decryption key, so many things, right? So it is better to qualify the words key with the appropriate title to avoid confusion. So in order to avoid, since we have lots and lots of keys in relational database model, so because of which it is always a best practice to write the full name of the key. Okay. Consider the following table. One is the element table and the other the shipment table. This where do we have the shipment table? All right, the previous one. All right, let me just create a one hyperlink so that we need not go 11. Okay, and then go to page 11. And then jump to this one. Okay. All right, and we are here. Shift F5. All right, consider the following two tables. One is the element table and the other shipment table. Let us take a look at the attributes item of the relation shipment table. It is clear that a given value for the attribute, say AU, should be permitted to appear in the database only if the same value appear as a value of primary key symbol in the element. Does it appear AU hi eta hianin thầy đàn chu if and only if this particular value appear under symbol and if that symbol is a primary key for that particular table. Is it there? Yes, it's there. AU is here, right? So such an attribute is called foreign key. So which one is foreign key? These are foreign key. right? These are foreign key. Because why? Let's take a look at the attributes item. We are seeing the attributes item of relation shipment table. It is clear that a given value for that attributes. This is just an example. All right, you can take AL also, FE also, AU also. They are simply trying to let you know what is foreign key. AU should be permitted to appear in the database only if the same value appears as a value of the primary key. So in order to appear under a foreign key of this particular table, this particular value must appear in the primary key of that particular table, which is correct, right? Or in other words, foreign key is an attribute or attribute of one relation whose value are required to match those of primary key of some other table. Also, the foreign key and the primary key should be defined on the same underlying domain. All right, it must have the same constraint, the same restriction. So this value should be from what's that? Element table. All right, and here also this value should be from element table and the symbol, right? We should insert only the symbol here and here also. So what are the primary key and what's that? Foreign key relationship. Likewise, we have symbol table and these are their attributes, whereas shipment table, their attributes. So this is the primary key for this table, and then this become the foreign key for that particular table. So these two values will be the same. All right, this value and this value must be the same if there is a relationship like primary key, foreign key. From the above discussion, we are now able to identify many integrity rule or constraint for the relational model. Relational data model includes several types of constraint, whose purpose is to maintain the accuracy and integrity of data in the database. The major types of integrity constraint are. So as we have seen, from the above discussion, we are now able to identify many integrity rules or constraint, right? Like domain constraint. In order to become a candidate key, what are the things they have to follow? In order to become primary key, what are the constraint? To become a foreign key, in order to create a primary key and foreign key relationship, what are the constraints? All right. So the stats are mentioned there, but it is not actually explained. So because of which we will be learning about what are different integrity constraints. So what's the main purpose of integrity constraint? It is to maintain the accuracy and integrity of data in the database, right? Constraint. The main reason of including constraint is to maintain data integrity and accuracy in the database. Number one is domain constraint, entity integrity, referential integrity, and operational constraint. So this will be a bit longer, but I hope we can understand easily. Domain constraint, what does it mean? All the values that appear in a column or relation must be taken from the same domain, right? In our previous table, we have talked about element table, right? Under that, we are entering all the elements from the chemistry element table, right? We cannot simply add Kuma or Kima or Michael Jackson or John Cena. All right, they are not from the element table. So domain means the source from where we are getting should be the same for one particular table. As we have seen before, a domain is a set of values that may be assigned to an attribute. A domain definition usually consists of the following components: domain name, right? Meaning data type, size or length, allowable values or allowable range if applicable. For example, in the element table, the domain for the column symbol is a character of length 2. So these things are like domain definition always consists of components. The length of the symbol should be 2. Such are the constraints and should be from the list of the elements, right? In other words, the domain of the column symbol is value whose maximum length is 2 characters and the first letter is uppercase and it should be. So there could be lots of constraints. like here tinan element table meaning ngay tu ni tin a character length ha 2 talun tu 2 a maximum ni tu ni ti te tro chuanin ani lo ponin a letter ma so capital ni nga thung so small in omang ti te bold letter ni tu ti te po kan du chuanin can be constraint can be. Similarly, the domain of the column atomic number is an integer and so on. The domain of the column atomic. Jadi entro column atomic number mi kha integer ni tur ni tini thung. Heta table kha ngai ruat 0 kan table ni to kha. That's for the main constraint. What comes next? Entity integrity. An entity is a person. We have talked about what entity is. Entity is any person, place, or things to be recorded in the database. Each table can represent an entity, and each row of table represents an instance of that entity. Each row of a table is called tables, represent an instance of that entity. Entity Let's see what is entity integrity. For example, if order is entity, all right, that means order is a table name. The order table represents the idea of an order. The idea of an order, and each row in the table represents a specific order. Is it clear? Each row, the actual content will be representing what are different order that the customer made. And then if it is order table, then all its content must be related to the name itself, order, right? You cannot simply keep lyrics of Dam Doi Moon and such, right? You cannot keep Blackpink lyric, okay? Because it's all about order, right? To identify each row in a table, the table must have a primary key. We have talked this thing. The primary key is a unique value that identifies its row. This requirement is called entity integrity constraint. All right, the entity integrity rule is designed to ensure that every relation has a primary key. All right, for what? For why? For what do they introduce this thing? The entity integrity rule is designed for what it is designed to assure that every relation has a primary key and that the data value for that primary key are all valid. Entity integrity guarantees that every primary key attribute is non-null. All right. It make it clear that the primary key anh này ngay tu ni kha ti chiang to phota tin primary key kha avalitem ti kha a chian le a chumi nuwa null ni lo null kan ti chu empty nil angka ani lo ni ti kha a chian le ta ni chu no attributes participating in the primary key of the base relation is allowed to contain nulls. All right, if they are under primary key attributes, no, we are not allowed to have null value under that particular column. Okay, thus a null primary key value within the base relation would be like saying that there was some entity that had no non-identity. All right, an entity that cannot be identified is contradiction in terms. Hence, the name entity integrity. In some cases, a particular attribute cannot be assigned at the data value. So, what does entity integrity means? Entity integrity is designed to assure that primary key are there and the primary key is a valid. All right, it ensures that there should be a primary key, and if there is a primary key, then it must be a valid, and if it is valid, it should not be null, right? And then if there is null, that means there are problems. So in the rules, there should not, in the integrity rules, there should not be any null value if at least that particular column is selected as a primary key. There are two situations where there is likely where this is likely to occur. Number one, there is no applicable data value, applicable data value is not known when the values are assigned. That means what are two situations it talks about when it becomes null, right? For example, consider a situation where you are filling out when the primary key value is null. Consider a situation where you are filling out your personal details. There is a column for fax number and you do not have fax number. You leave the field blank. This is example of no applicable data value. All right. Since you do not have, suppose you use fax number as a primary key, but if you do not have fax number, I do not have fax number, so still I'm among the member of that particular table, but that particular field cannot be filled. I think you got it. That FIELD cannot be FILLED. You will leave that field blank. This is an example of non-applicable data value. All right. When does those two situations arise? That means when does the primary key attributes become null. So when we do not have that actual value. In other case, suppose you are filling an element table. Consider an example of nickel. You know that nickel is having a melting point. Right now, we do not know the value of the melting point of nickel. So because of which you fit blank for time being. So because of which you null value attributes. All right. Which you have to fill it later. Okay. Suppose you are taking the atomic number as a primary key and aluminum, nickel, what else? Iron, Fe. So many things are there, and you know their boiling point. So you are filling up everything, but when it comes to nickel, then you forgot the. You know that there is a boiling point for nickel, but you do not know it right now. So because of which you keep it null. All right, and null is a value that is assigned to any attributes when no other values applied or when the applicable values is unknown. In reality, a null is not a value, but rather the absence of value. All right. For example, null is not the same as 0 for numeric fields or blank for character field. 0 if it is if you are supposed to enter numeric number on that field, it will become 0 for numeric. I mean, it is not same with 0 for numeric, and if you are supposed to enter like AL, then it cannot be blank. The inclusion of nulls in the relation model is somewhat controversial since operational involving null sometimes is true unpredictable result. On the other hand, using null for missing value is a good idea, but whatever the pros and cons of using null, it is imperative that the primary key values be non-null. All right. Though you may be, they may be introducing this null for or some particular value which you do not know, but it is always sometimes it creates confusion and sometimes it is useful as well because later you can feel it when you keep null. So in such cases, it is always imperative that primary keys should not be null. All right, and then referential integrity. After this, we still have one more. Referential integrity refers to the relationship between tables. Because each table in the database must have a primary key, this primary key can appear in other table because of the relationship. Also, this is referential integrity means those kind of relationship between foreign key and primary key, which we talked about before. Tables can form a hierarchy of dependency in such a way that if you change or delete rows in the table, it will destroy the meaning of, like I've said, primary key and foreign key relationship will be established if the value of if the attributes of a original table is present in the other table, then that particular attributes can become a primary key for that a foreign key for that particular table, right? So if you delete that particular row, I mean column from this table, then it will affect this foreign table as well. In relational table, system between tables are defined using foreign key. For example, the system between elements and segment table is defined by including symbol attribute and foreign segment table. This implies that before we insert a new row in the segment table, the element for that order must already exist in the element table. If you examine the rows in the you will find that every item name in the table appear in the element table. All right, what does this mean? If you are to if you are wanting a new value from in the shipment table under symbol item, right? So you must first always insert the value to the value in element table under symbol column. After a referential is a rule that maintains consistency among the rows of the table. The rule stated that if there is a foreign key in one relation, either its foreign key must match primary key value in other table, or else the foreign key must be null. All right. What does referential integrity? If there is a foreign key, then it must always match the if there is a foreign key in either its foreign key must match the primary key value in other table, or else the foreign key value must be null. All right, this value and this value must always be the same, or if it cannot be the same, then the value here under the foreign table should be null. Okay, if base relation, see, we have some other relation. All right, this is not that much important. Sometimes it is necessary to permit foreign key to accept nulls. Here it must be noted that the null are of variety value does not exist rather than value unknown. All right. Hết tạo về thông số in null kan tạo về thông kanin. Hết lại cái in value value unknown le nghe ka kan bi vang kanin primary key ho ya null kan da hemi null kan da về thì nó chân sẽ chú value om lo thung kan shit lo van le win om lo van zo again. All right, last one, operational constraint. There are constraints enforced in the database by the business rule or real-world limitation. For example, if retirement age, these are the constraints enforced by the business to the database. All right, I think we have talked about this constraint before. Consider if the retirement age of the employee is an organization is 60, then the age column of the employee table can have constraint. Age should be less than or equals to 60. This kind of constraint enforced by the business and the environment are called operational constraint. Operational constraint can be two constraints that are introduced by the organization in order to maintain their rules, right? Their administration rules, like employee should be retired by 60, and employee can start joining only when they are 20. That means the range will be 20 to 60. All right. Likewise, they can have a constraint. I talk a little bit fast because the time period for recording this is 45 minutes. So I am afraid that I will not be able to finish within time. If you have any question, then you can ask me at any time. And with this, we are completing the unit 2, and I will be giving you assignment this time to find the characteristic of relation. Characteristic of relation I'll be posting in the platform as well. And from the next class, we'll be learning the practical part. All right, so please the video and try to have some questions regarding the topics. I may be talking a bit fast, but I hope you can rewatch it later with a slower version as well. Okay. All right. That's all for today. Thank you.